As always, please remember to pause in order to write down any of your vocabulary words. Really quick, term. Term is a part of an equation separated by a plus or a minus sign. Constant is a term that is just a number, no variable. Like terms are terms that have the same variable, and coefficient is the number that you find in front of the variable. All right, coefficient is the number found in front of the variable. So I'm going to give an example here, and I'm going to show you how each one of these applies to that example. So first, let's take an expression, and an expression is something without an equal sign. I'm just going to write it right in the middle here. We're going to have 3x minus 2y plus 7 minus 2x. So first of all, let's talk about terms. Terms are parts of an equation or an expression separated by a plus or a minus sign. So when I'm looking here, I see there's a minus sign here, a plus sign here, and a minus sign here. I could take these and create them into something different, but at this point in time, I'm just going to leave it the way it is. So that means each one of these is a term. This 3x right here, that is a term. This 2y right here is a term, 7 is a term, 2x is a term. They're separated by the plus and the minus signs. What I was referring to a minute ago was this. There are times where we talked about we don't like subtracting, we only like to add, so we go tick, tock, tick, tock. And what we do in essence is we make that every single term is now separated by a plus sign. And so I have a term of 3x, a term of negative 2y, a term of 7, and a term of negative 2x. And that becomes important a little bit later when we talk about combining. All right, so those are the terms. So in this case, there are 4 terms. 1, 2, 3, 4. A constant. A constant is a term, so one of these 4, that has no variable. I'm going to remove the circle blobs here just so it's a little bit easier to see. This has a variable, so that can't be a constant. This has a variable, and this has a variable. None of those are constants. The only constant here would be the positive 7. It is the only one that does not have a variable. Now we have like terms, terms that have the same variable. So once again, I'm going to remove the drawings from earlier. So now I know that I have a variable, and that they're a term, and that they have the same variable. So here's a variable x, here's a variable y, and here's a variable x. Which ones are the same? The x's are. I'm just going to throw them into triangles really quick. So 3x's and negative 2x's. These are like terms. This 3, this constant, or this coefficient in front just tells me how many I have. I have 3 x's. This tells me I have 2 x's, but they're being subtracted. They're of the negative value. That's a little bit more difficult to write. But that's all that number is telling us there. And that number is the coefficient. It's the number found in front of the variable. What is really important to know for today's lesson is like term and term. Constant and coefficient you would need for some examples, but term and like terms are what's going to be repeated over and over again. All right, so when we're talking about terms and like terms, I like to start with shapes. And if I was to ask you, what is 3 stars minus 2 stars, you'd be able to tell me. 3 stars minus 2 stars is 1 star. And then I have to add 4 stars onto that. Well, 1 star plus 4 star is 5 stars. Pretty easy, that's not a problem. Okay, cool, I get this. Then I'll look here at number 2. 4 stars minus 3 hearts. If you were holding a bunch of stars in your hands, could you give me hearts? Well, no, you don't have any hearts. All you have are stars. So I cannot combine these. These are not like terms. They do not look the same. How about here? An arrow. Nope, arrow is not the same as a heart. Arrow is not the same as a star. I cannot combine any of these. Let's look at number 3. 5 triangle and 4 triangle. These are the same. I can combine these. So I'm going to write them down here a little bit separate. And now I have 5 triangles minus 4 triangles. 5 triangles minus 4 triangles would leave me with 1 triangle. And that takes care of the triangle portion. But I still have the semicircle here. So I still write minus 4 semicircle. That is my final answer. I can't simplify it anymore. I can't combine any more terms. A triangle is not the same as a semicircle, so that's it. It's done. However, in your homework, it's not going to be as simple as stars, hearts, arrows, and semicircles and triangles. We're going to actually have some word problems. So I'm going to start with a problem like this. And what I want you to do is look at the like terms and put shapes around them. I'm going to start with the N, and I'm going to put circles around anything I see with an N. I'm always going to circle the number and the sign in front. In this case, I don't see one, but I know it's a positive or a plus. I see another N here, happens to be a negative 7N. And I see another N here. And a lot of people miss this one, but you can't skip it. It's still here, it exists, and there's this magical little 1 that stands in front of it. Now I have all these, and I'm going to put them together. 6N minus 7N plus 1N. Well, if I had 6 of something, and I took away 7, well, then I'd have a negative 1 of that. Negative 1 plus 1 is 0. This completely cancels out. It combines out. Turns into a 0. That takes care of all the N's. The only answer then left is the negative 4. Notice I put it in a different shape because it's not the same as the N, so I can't circle it. But now I have 0 minus 4, and 0 minus 4 is negative 4, and that's my final answer. That is just fine. That's an acceptable answer. So let's look at number 2, or the second one here. I'm going to do the same thing for this problem. I'm going to take my time, and I'm going to set it up with boxes and circles just to make sure that I'm noticing what are my like terms. I'm going to start with my y's. I have 9 y's here, and I have negative 11 y's here, the number and the sign in front. Are there any other y's? Not that I can see, so I know I have 9y minus 11y. Then behind it I have a constant, because it has no variable, of negative 4 and a positive 7. So I have a negative 4 plus 7. Doesn't matter how you solve these. Some of you have picked up enough from the integer work that you can just look at this and know the answer. Others might have to go tick-tock, which is totally acceptable. The negatives are going to win. They're going to win by 2. So that's a negative 2y here. Here, negative 4 and positive 7, the positives are going to win by 3. This is your final answer. You cannot combine anymore. And I know a lot of you don't like the way that looks. You would rather be able to get it down to a single number. But you just have to be okay with this being your answer. It's not going to be a single digit anymore. Well, sometimes it will be, but not always. All right, we're going to look at this problem. I am going to change it up here really quick. We're going to make that an 8x. All right, so let's look at this problem here. I have to combine like terms again. So I'm going to come through and I'm going to circle the terms that are the same. These are the same because they have the same variable. And these are the same because they have the same variable. Notice I took the negative sign with it. Then I'm going to put boxes around this too. I can't put a circle because circle went around the x's. And if I put a circle here, that would mean they're the same, and they're not. And I'm also going to put a circle around this one. I'm sorry, not a circle, a square. Hopefully some of you caught me there. I'm going to put a square around this one. It does not have an x. Now I'm going to combine my circles. I'm going to put them both together. So I have 3x minus 8x. And I have a positive 2 minus 10. Tick, tock. Tells me, let's see, I have 3 positives, 8 negatives. Negatives are going to win. 8 is 5 more than 3, so it's going to be a negative 5x. And here I'm going to do tick, tock again. The negatives are going to win. 10 is 8 more than 2. So then I'll put these together. Negative 5x minus 8. Side note, if you happen to solve this and you did it a different order and you got negative 8 minus 5x, that's the exact same answer. That is just fine. It's in a different order, but it's going to give you the same result. Negative 8 and negative 8 go together, and negative 5x and a negative 5x go together. So that would be acceptable for that. Let's try some easier problems. 7x plus 8x. Well, this is just telling me to add. It's like I have 7 x's. 1, 2, 3, 4, 5, 6, 7. And I'm going to add 8 x's to that. 1, 2, 3, 4, 5, 6, 7, 8. Well, if I was to count these all up, I would end up with 15 x's. And that is, again, totally acceptable. And that's how you solve that problem. So this one is telling me 3r's minus 2r's. If I had 3 of something and I subtracted 2 of something, I am left with 1 of that something. And in this case, it's an r. 3r's minus 2r's is 1r. Remember what I said about that little magical number, 1. If I don't see anything here, it has a magical 1. So this is telling me I have 8g's minus 1g. 8g's minus 1g is 7g. That's it. That's your answer. Just subtract them. I don't like this first problem so much. So let's look at this bottom problem down here. I'll drag it up a little bit higher. Let's look at this problem right here. Again, don't feel foolish if you have to draw the circles and the squares. Taking the time to do that will more likely ensure success. So I have a G here, not a G, not a G, is a G. Regular number, I'm going to put in a kind of a triangle, and another regular number, I'll put in a kind of a triangle. So now I want to combine my circles and my triangles. My circles are 2g's minus 8g's. 2 minus 8, tick tock, negative's going to win by 6. And then here I have 3 and 11. Negative 3 plus 11. Positives are going to win by 8. So I have negative 6g plus 8. Final answer. I can't combine this. I can't say 2, 14, negative 14, nothing like that. This is my final answer. Alright, let's talk about some of the word problems here. You have saved some money. Your friend has saved $50 less than you. Write an expression in simplest form that represents the total of money you and your friend saved. So here is you, here is your friend. We don't know how much money you spent or saved, but we're going to call it X. You saved X. We know that your friend saved 50 less than you. So if this is how much you had, take 50 away from that, and that's how much your friend has. I want to know the total amount that you saved together. So you plus the money your friend saved is your total amount. Well, now slow down and look at this. Like term, like term. What's X plus X? 2X. And then minus the 50. That would be in simplified term form. At a concert, you buy some souvenir t-shirts for $12 each and the same number of CDs for $7.50. Write an expression in simplest form that represents the total amount of money spent. So I know I had t-shirts and I know that I had CDs. I'm going to have t-shirts equal X and CDs equal Y. You could pick C and T if you want to, doesn't matter the variable. I know that the number of t-shirts I buy, or the t-shirts are $12 each, so 12 times X. And I know that the CDs, I'm going to add on the price of the CDs, which is $7.50Y. However, they told me that I bought the same amount of each. Where did it say that? The same number of CDs. So that means I can use this variable for both of them because I bought the same number. So if I had X is 4, then X would be 4 here. And the reason they had us do this is they wanted us to combine it together to make 1950X. So I bought 1950 times however many of the products that I bought. All right. Your homework was listed down here at the bottom. Again, you may have to pause it. But all I want you to do is just slow down and use the triangles, use the squares, and use the circles.